Okay, so this is I guess, a rejuvenation of the Ada Mode podcast, where we're joined today by a couple of Ada Mode people and myself, Jack, one of the founders of Ada Mode. So I'll do some quick introductions. We've got Dan with us here and Michelle. Do you want to just give a quick intro as to who you are and what you do in Ada Mode?
Yeah, I'm Dan, one of the co-founders. Background in sort of science and engineering, but yeah, I guess I sort of sit between people who are more focused on engineering problems and challenges and what solutions to those might look like, and then data science and development team, sort of bridging the gap between those two ways of approaching things.
And I'm Michelle. I am a front-end developer, so I'm responsible for user interface design and development. So basically what the end user sees and interacts with in our applications.
Cool. So today we thought it'd be good to try and explore a little bit as to what Ada Mode does through the lens of some work that we've done in the past, over the past 6 years since we began in 2020. And the topic today is looking at software development, predominantly AI-driven software development, and how that compares to the wider perception of AI from the public, and the differences compared to what we actually do in terms of developing software for industrial operators and industrial players. There's a big sort of spectrum between the two, and actually building solutions that have to meet operational needs and drive value in some way is a lot different to what perhaps the public perceive it to be when they're interacting with things like ChatGPT and other AI software. So that's the focus of today, trying to understand the difference between those two elements and really what key enablers and elements of software development you need to focus on to have a successful deployment of an AI solution in an industrial setting. So perhaps the first thing we could do are talk about what sort of problems industry is trying to solve. So we talked about the public's use of AI and the tools that people use, things like ChatGPT and Copilot. But maybe Dan, if you could sort of elaborate a little bit on what sort of things industry is trying to use AI for, and what value they're trying to extract from it.
Yeah, and I guess there's sort of two main groups. There's things that everyone's dealing with, or every large businesses in general, or lots of society are sort of looking to use AI or software to be more efficient in certain ways or automate certain tasks. And then there's bits that are a bit more unique to specific businesses and to industry. And it's often those parts that have quite old-fashioned software, or the things like modern user experiences are pretty lacking, or not as really as thought about, I suppose. And that might be challenges around dealing with loads of operational data, handling how you prioritize planning and operations of things when you've got limited resources, all sorts of quite specific challenges, which don't necessarily have a general product or solution that you can buy or subscribe to, and that starts to fix your problem. Or if people try that, they often then realize that it doesn't quite fix their problem, and you end up with multiple software systems that don't really get along, and then you end up trying to unpick that challenge, and you sort of create a difficult situation out of multiple IT systems. So it gets quite complicated in those situations. But there's lots of scope to do this more intelligently and really get at value by building products that are a bit more focused on those specific challenges, but built to get along with other software and be a bit more scalable and integrated into how your business works.
So some of the things we deal with are things like availability of plant. So that takes various different forms, but in a power station setting, that's something like being able to produce power for longer, more reliably at a rate that's close to your peak output. In a manufacturing setting, that is producing some product or some output in a consistent way at high quality for as long as possible. And then there's things like reducing waste. So waste might be energy, but it almost might be consumables as well. All the while you want to retain quality and reliability as well. So it's sort of creating a balancing act ultimately to produce high quality output as cheaply and as efficiently as possible, and as critically as safely as possible. And that's quite broad, but there are a huge number of sort of niche applications of particularly AI in that area. And then you have layered above that all the sort of, not standard, but all the similar operational challenges you have in any large organization with a workforce that's diverse, that's disparate, that has different skills. So managing the workforce and the productivity of that workforce is also a huge challenge for some of the organizations we work with. And there's a lot that AI software can help to drive efficiencies there as well. So maybe if we sort of touch on the different types of solutions that can be developed. So maybe if we sort of reflect on what we've done in the past 5 years or so, sort of chat around some of the different types of solutions we've built. So things like predictive maintenance, all the different modeling, the large language type solutions, simulation elements, and how they, I guess, drive towards an outcome that perhaps organizations weren't able to achieve through traditional methods. Do you want to touch on that a little bit?
So I can talk a little bit about that. So a lot of the work that I've been doing with Ada Mode has been around predictive maintenance and building interfaces where people can visualize and interact with the data from their plant or from their systems. So they can zoom in on particular parts of the data, they can compare data from different sources and make informed decisions. Also, some of our systems can raise alerts when certain systems are not going to plan, let's say, where data is kind of deviating from what's predicted, what's expected to happen. And that can alert people to a problem before they would have noticed it as a human, and it enables them to react quicker or react preemptively rather than reacting after a problem has already happened. So my work is concerned with building visual interfaces that allow them to interact with that better.
Yeah, I think that human element is really important and is a key difference between sort of mainstream AI or broad AI compared to what we tend to focus on in narrower AI and bespoke development. What are the sort of key aspects in your experience in terms of building something that people are going to reliably use, recognizing it's the type of people we're building solutions for have worked in a specific area for a long time. They're highly skilled in that specific area, often used to established ways of work, enshrined in governance by the bigger business, and also have their own experience to sort of draw on, and that's how they execute their day-to-day work. What are the sort of key parts of making sure that what we're building is going to be sustained and adopted in a way that is embraced and maintained for a long time?
So I think it's really important to speak to people in their language. So part of our job is doing the research really well and talking to people in the environment where these systems are going to be operated, understanding exactly what they need and the language that they use when they're using these systems as well, and ensuring that translates over to what we're building so that it's as easy as possible for them to use and can be sort of hopefully seamlessly integrated with their existing systems and processes, and making sure we listen to their feedback as well. So certainly on projects recently, we've had some really productive sessions with a lot of stakeholders that are going to be using our products that we're building, and making sure we take that feedback on board and, don't be too precious about, how we think things should be, making sure we are building for the user, not for ourselves.
Yeah, yeah, definitely. And that sort of integration piece you mentioned is hugely important and relevant in the work we do. And it definitely encompasses the user side, but also more often than not, the challenges aren't necessarily with the the sort of integration of AI, but the ability to integrate with existing systems and data silos that are typically quite disparate and different across not only an organization, not only different organizations, but within departments within the same organization. What are the sort of, based on your experience, Dan, what are the key things to consider when thinking about developing something bespoke into an established IT infrastructure that's wrapped in the governance of a large organization?
Yeah, it's one of the areas that's pretty challenging because the particular clients might have quite different IT systems. There may be other constraints in terms of information security. Some clients might have a really modern cloud environment where it's easy to build apps in quite a straightforward way. Others will have much more complex and constrained environments, legacy environments, challenges with where data can go. So really it's about understanding what that picture looks like, what the constraints are. It might be that the client might be keen to adopt new ways of working, or it might be that we really need to stick with how things are. So understanding what we're able to do, basically, and then being pretty flexible to do as much as we can within whatever environment we have available. So even if that includes connection to legacy data and on-premises deployment on older systems, you can still build machine learning models. You can still have a modern UI UX. It might make the development a bit more complicated up front, but it's still possible to build apps in a situation like that.
I think it's so important to be able to build trust as well, trust in our processes and in our models, and having that sort of transparency with clients so that we can tell them exactly how their data is being used and how it's being trained, helps deliver that trust, because they're not going to use a system if they feel they can't rely on it to make accurate decisions.
Yeah. And I think part of that is a collaboration. So working really closely with IT teams or data science teams in a collaborative way as much as possible, recognizing what you said, Dan. There are, in some cases, limitations on what you can open up and what you can share. I think moving towards collaborative environments where you can share code, review code, iterate, deploy in a really agile fashion is a really is not too far off in the horizon in a lot of the work we do, and really sort of striving to get to that point. I think we'll unlock a lot of efficiency, but also a lot of insight and value in terms of deployment of a broad range of sort of AI archetypes, if you like, to really focus on those niche operational challenges that we experience.
It's one of the areas where I guess industry, like plants that operating generates things like time series data, it's very different to a sector like retail, like online retail, where loads of data science work was kind of grew out of that, or we're very familiar with recommendations for things that you might want to buy. There's loads of predictive modeling that goes on in environments like that, but they were, they're modern environments that really lend themselves to quick and easy application of those things. And if you get it wrong, someone doesn't click and buy, it's not that big a deal, yeah? So the consequences in environments that are lower, industry has more complex time adopting modern IT environments and has to think much more about what happens if this system goes wrong, and can we trust it, should we trust it, and what does trusting it look like on day one, and what does it look like after you've had that embedded for a few years?
Big part of what we do or what we experience, not just in terms of software development, but in a lot of the projects we engage in throughout that life cycle. So we might do elements of software development, but not wrapping in to the whole end-to-end application build. We might do some data engineering work, some model development, some enhancements to the front end. All of this is, particularly in the areas we work in, has a lot of scrutiny from not just the organization that we're building the solution for, but from often the regulator that isn't regulating AI directly, but is regulating the industry that you work in. What do you think the sort of role of the regulator and sort of broader government and developers like us and client organizations, how should those discrete entities interact to move, I guess, the dial on building AI-driven software faster, more reliably, and with more regulatory compliance, recognizing there's uncertainty in all these areas, over the next sort of 5 years or so? Big question, I know, but it's my sort of view on this is that there's a lot of dialogue between everyone. There's still a lot of uncertainty on how it's best managed, how it's integrated, how you get assurance and build robust, sustainable solutions. What do you think the sort of, maybe a better question is, what are the sort of key things to consider and next steps from a UK perspective?
Yeah, it's a really interesting area because I guess the UK's approach to regulation tends to be goal setting. So it's sort of intrinsically flexible. It doesn't say you can use AI, you can't use AI. It's asking people who are being regulated, so operators of plant, to demonstrate that they're acting in a safe and defensible way. So you could introduce an AI system in that context, but fundamentally they present challenges to how things are normally done and the sorts of arguments and the kind of evidence you need to provide to substantiate or prove that you're operating something safely. So it does produce challenges, but it's possible within our regulatory framework. Mm-hmm. And I think those conversations around it are key, basically, to getting operators to start to bring solutions to the regulator, start talking to them about things they're thinking about. A challenge as well is for the regulator to be able to assess that information, because you might be getting into pretty challenging, difficult stuff that the regulator don't necessarily have expertise to review. I mean, in what we're talking about here, we're going from human factors, UX, UI. So there's all the questions around how people are taking insights, the decisions that they're then making. But that's all built on data pipelines leading to plant data, a load of machine learning models, which might be a whole suite of models based on different technology, some statistical and explainable. So you could say, yeah, it's predicted this because of that. Relatively easy to explain what it's doing. Some of the models are more black box, as people say, where they see information, they generate an output. That's more challenging from a validation point of view. So there's sort of various parts of the whole process which really need to be thought about carefully in order for an operator or licensee to be able to go to the regulator and saying, we have this new AI system. It's not making unsupervised decisions. It's supporting and informing and helping staff who are making it better informed decisions.
Yeah.
And we've validated the performance of this system within this operational space. And if we go outside of that operational space, the system doesn't generate data it shouldn't do, doesn't mislead people, doesn't behave in an unexpected way.
Yeah.
So there's quite a lot of defenses and guardrails that need to be built around AI systems within environments which fundamentally are risky environments, industrial safety and consequences when things go wrong. So important that those guardrails are in place.
Yeah, I often think as soon as you introduce the concept of AI to a problem, the focus very much lands on the AI element, and the bigger picture can sometimes be missed a little bit. So I think you need to assess the solution you're building, whether that's an AI solution, a discrete event problem, a non-digital solution, in the broader context, and look at the wider risk that you're operating in, the wider sort of window of risk that you're operating in, and treat it in a sort of, I guess that's the sort of more traditional way of looking at safety cases and risk assessments.
Have you improved your risk position?
Yeah.
Because often, people's response with AI is so I might get this wrong. But if the status quo is it's not being looked at, or people are giving it 1% of their attention and they likely make mistakes with it, then you don't need a perfect system in order to improve on that. It depends on the context, I suppose, over whether you can really make an argument for that. But in some cases, I think you can.
Yeah, cool. Okay, so maybe if we sort of turn this around a bit and think about not only new technology but new facilities or plants, be interested to get your views on how a new facility or a new plant that's either being designed or built should gear themselves up for effective adoption of contemporary digital, in brackets, perhaps AI solutions once the plant is commissioned and in operation for long term. What are the sort of key components or key sort of pillars for success, based on what we know from operating on legacy plant? If you were building a new plant tomorrow, designing it tomorrow, what would you make sure is in place to make sure that in the future you're able to quickly adopt and with agility contemporary digital technology?
I think it's really important to have somebody sort of on the inside, on the client side, who is knowledgeable, certainly to an extent, about AI, about sort of digital technology. Because certainly in our experience, where we've had a client who has been, interested and knowledgeable and pushing for that strongly and pushing for these AI solutions, it has eased the path somewhat to getting these things adopted.
Yeah, I totally agree. I think skills is hugely important in empowering the workforce to A, challenge, but B, create solutions for themselves in a way that is managed appropriately through appropriate governance and processes is really important. So it also, having that real strong internal skill capability, enables really effective collaboration with people like us and other third parties. And I think the collaborative part is really key there. So you can have an intelligent customer working with a solution provider that can really drive towards something with minimal blockages during that sort of the course of development. What about you, Dan? Any thoughts on?
Yeah, I guess access to data is one of the persistent challenges. We might be doing projects where we're interested in time series machine data from plant to train models to understand the plants, but also we'd be interested in, say, maintenance records, downtime records, different information about two different silos just there. But there might be a few silos that we're interested in looking at. Some of it might be spreadsheets or reports in some environments, so pretty unstructured, messy legacy type data. Ideally, having a better open access to data, or at least the ability to relatively easily grant access to data in an environment where you can actually build and deploy something. Because there's emailing someone a CSV, and that's maybe useful to do a feasibility study. We can train a model that can predict this variable, and it seems to be effective at detecting this known fault, for example. So you could align your time series data with some historic maintenance records, but ultimately you want to deploy something which is consuming time series data continuously, and that's often a challenge as well, that the environment won't necessarily be there that's designed for or ready for that, or the organization may not be used to working in that way. So I think those are areas that are challenges for us. So for newer plant, helpful to be planning for integration of data, ease of communication, and flexibility, I suppose, of hosting environments for more modern application types.
Yeah, and I think just to build on that, having a really good relationship between the physical environment and the digital data model that is consistent across the whole asset base is really key. So defining your sort of hierarchy, your structure of how you operate. So that might be something like a building, a facility within a building, a plant within a facility, a system within a plant, and then a component or something within a system. And scaling that across the organization, and then using the same structure for your data model is really key. And then layering your governance and processes against that data model, but from the bottom up, not from the top down. So your asset hierarchy and your operational needs are informing your processes, not the other way around. Because the other way around forces you to operate, in my view, in sort of a suboptimal, inefficient way.
Paperwork constrains the plant.
Yeah,
almost.
and obviously you have to consider, safe, reliable operation and compliance with license conditions or other health and safety commitments as well. But that won't be overlooked during the design of the asset base, because that is inherent to any part of the process. So the sooner you, I guess this boils down to as soon as you have an operational philosophy and structure, you need to create your digital equivalent and build your systems at the same time, not bolt them on when you're approaching commissioning. Because the tendency is to look at the number of cranes on site, the amount of concrete being poured in a day, the amount of people moving through the gate. Are people looking at how robust is the data structure that's going to operate this plant? How broad is it? Is it aligned to your asset hierarchy? Is it going to give insight? I don't know. Probably is in some places, but I'm pretty certain it's not in a lot.
Yeah, we're often backfitting some of those considerations or coming to them a bit later than perhaps the ideal. But I think that's something that's being recognised relatively broadly, that the earlier you plan for digital integration, the better your construction project can go, the better your ops can go, better commissioning can go. So it is starting to be something people think about earlier on. But yeah, it's often the case that a lot of work is involved in trying to reconcile challenges that arise from doing digital integrations a bit later than perhaps be optimal.
So that said, how, because we're in real life here, we're not every industrial facility is going to be built tomorrow. There's a huge legacy of plant and factories and power stations that will operate for many years. What would be the first things to consider if you're doing a broad retrospective on digital strategy with an operations lens for an established plant? Where would you sort of look to go first to say, I want to bring this to the 21st century, 2026, recognizing the rate of change of technology is enormous now, compared to even 2 years ago. The rate of development of particularly AI is huge. How do we make sure we're sort of future-proofing as best we can, given we've got all this operational legacy, all this baggage, and we have these limitations? Where do we start?
Challenging.
Yeah.
Where's the biggest pain, I suppose, is where you might start. Or where's the biggest benefit to be gained? So with legacy power station, it might be optimizing outages, better understand, learn lessons from historic outages, start to enhance the amount of monitoring that you're doing on equipment. And you can get a lot from doing that, even in a modest way, especially if the current approach doesn't involve much modeling or much sort of structured analysis of data between outages, for example. So I think if there's particular areas where there's quite a lot of value to be gained, attack one of those and try and make progress with it. And through that, you create sort of an example, because this is likely operators that aren't used to working this way. So a big top-down enterprise-wide change to roll out this new AI system is likely not to be that successful, whereas a focused project in which you say we're going after this value, we're going to relatively quickly demonstrate that we can get that value. And in doing so, we create sort of an example of what this could look like for the broader organization. So almost be ambitious with the vision for it, but in a realistic and achievable way.
Yeah, I think you also need to look at cultural factors within the organization
Definitely.
as well, because, are there people who are disincentivized from sort of implementing any kind of change because it actually reflects badly on their job role and would impact them adversely. So it's about sort of motivating people in key roles and actually empowering them to feel like they can bring in something helpful rather than them acting as blockers.
Yeah, definitely. I think you need to work with champions of innovation, I suppose, but try and bring it closer to the pain, which is always difficult to do sometimes. Well, not always difficult to do, sometimes difficult to do, bridging the gap between the perception of innovation type projects and I need to produce this amount of stuff in this time period, or KPIs are going to drop below an acceptable level. So you need, finding someone or a group of people that can support, understand sort of the bigger picture and understand that you're trying things differently. It may, I can see this being a potential problem, so I'll unblock that. And working in that sort of way is really effective. And then the key part of it is making sure you communicate it afterwards, because it's often the case that you do all these really good projects, deliver a value to a niche part of the business, but the learning from it isn't disseminated effectively, and the opportunities to improve X, Y, and Z over here can fall by the wayside a little bit. So as engineers and sort of data scientists and software developers, it's easy to sort of begin and end on the technical spectrum, but actually there's the bit before that, so engaging all the stakeholders, and the bit after it, communicating and disseminating, is hugely important to building sustainable solutions in the here and now.
AI is pretty challenging there because it means different things to different people. There's no consistent definition.
Yeah.
It's very hazy, very vague. There's a lot of noise about it and what it is. So I think people's general perception of AI systems might be very far from the sort of thing we're talking about here. So a model that predicts a known historic failure on plant, or a model that gives you a health score for part of a system that sort of sit in the background, and then you see an alert or some visualization output from that, but it's quite different to people's general perception of what AI is. So you have that challenge around communication, and then there's also the challenge around just perceptions about automation, threat to people's jobs.
Yeah.
Do people want to support an AI system that's going to take their job away? Is a risk that people might feel. So I think a big part of that is around communicating clearly and designing systems which are about the empowerment of people, which is where the UX side comes in, really strongly as well. Because ultimately, by engaging with those users to say, how can we build something that will help you do your job better, delivers insight to the user, you're operating the plant better, those KPIs look better as a result. So it's really about supporting people, but initial perceptions might be a bit more guarded. So definitely a challenging area, or I want to look out for, to make sure that you explain what it is that the project's about and you get people on side for it.
Yeah. So on the sort of UX, UI sort of user elements, what are the sort of key components of a successful development process, and at what point do we engage, and what happens throughout that build, and then how do you make sure we deliver, or how do we make sure we deliver something that can sustain and be adopted in the longer term, but also be adapted to fit as needs change over time? do you think?
So I think for me, sort of designing and building in a very modular way is crucial, because quite often, we'll build something, we'll deploy something, and then, realize it's not quite right. We want to sort of change the structure a little bit. We want to move things around. So having that sort of modular design where you can sort of break things up, reposition things, and make those little improvements is really important. But also, I think in the design process, sort of really looking at what is it that the user wants, what is it they need from this particular view. And what is the important information? Because certainly there can be a tendency with this sort of data visualization work to think, well, everything's important, and you can end up with views that are very cluttered, and you don't draw attention to any one particular thing because everything is shouting for attention.
Yeah.
So I think it really does boil down to what's important, what do they need to know right now, what can they then take the next steps to explore if they want to find out more information.
Yeah.
So that's generally the process that our UIs go through, I guess.
Yeah.
But then also, you do want to get feedback from the client, but you don't want to sort of jump in and do that too early, because I think people don't always know what they want or what they need until they've seen something concrete. So it is very difficult for people to feedback before you've shown them sort of a working prototype sometimes.
Yeah, that's an interesting point. And something we've come across quite a lot over the years is people don't know what they want because they haven't experienced similar sort of solutions in their day-to-day life in the past. So because we tend to be operating in the relatively contemporary cutting edge side of industrial software development, certainly you're often speaking to operators, engineers, stakeholders who haven't necessarily experienced the what the solution is potentially offering, and therefore they're sort of the art of the possible boundaries are a bit narrower than they could be. So how, I think you touched on it there, sort of building it in a modular way that can be expanded as they see the art of the possible and it becomes a reality. That's a really interesting sort of part of development that isn't, I don't know if it's that common in other areas, because the ability to add new features or add new capability is much faster in software than it is in other sort of traditional engineering, because things are getting built and packaged and shipped every day. Something new is coming out. So it's an interesting sort of cultural piece as well as a sort of technological piece, and the integration of the technology, coming back to what we talked about earlier, into existing systems is also faces that challenge, because I think we're seeing it more recently, but the flexibility of being able to integrate new things much quicker isn't there. So yeah, I'm not really sure what I'm getting to here, but it's sort of come into my mind throughout this conversation.
Yeah, no, there is also that push-pull as well, because you also kind of need to consider what patterns people are already familiar with and what systems they use at the moment and the way that they're used to interacting with data. So sometimes you might bring elements of that into the UI because you don't want it to be like so completely different to anything they've ever used before that they're actually a bit lost.
Yeah.
So there are, a lot of existing design patterns for sort of data visualization and data exploration software that we might sort of bring in to some degree. And certainly on our work with LLMs. So we haven't really talked about it in this conversation yet, but building like a chat interface for certain applications where people are having to look through thousands of documents. I'm sure you can explain a little bit more about that, Dan. But certainly building the UI for that, people are used to using chatbots now, like ChatGPT and other AI chatbots. So we didn't want to build an interface that's completely different to any of that. We want to take the patterns that they're used to and familiar with.
Yeah, and that's an area where, post the release of ChatGPT, I don't know that any of the sort of large or well-known AI chatbots really look that different. They all basically have the same UI for that reason, I guess. But yeah, I guess keeping things familiar for people, easy to use, intuitive, and coming from more legacy software that might be deployed in an industrial environment, that isn't necessarily what they may be used to. That they might have had pretty difficult to use software for a while, much more limited in terms of how they can view things, how they can use it, and certainly in terms of their ability to influence it and change it, and the pace of that change. So having a project where we're actively engaging with engineers who have been sort of frustrated by an old system, and they're transitioning from that to new modern UI UX, but also the ability to say, well, let's have a development pipeline here in which we get this core functionality developed, but then we can expand and build on that, and we can continue to improve it and add features and have it more of a living piece of software.
Cool. Right, I think we've probably covered some good ground there. I'm happy to call it a day, but good conversation, good areas that we've reflected on. We've touched on sort of the key components of how industrial software, particularly AI-driven software, differs from sort of mainstream AI software, the sort of things to consider when building something for an industrial user, an engineer and an operator, and considering that's typically within a regulated industry that has a lot of other factors to consider and forces at play beyond the sort of immediate needs of the user, and the sort of techniques and key considerations, particularly around the user interface design and user experience, which are really important in terms of landing a solution that is going to drive value, normally around sort of efficiency gains or quality gains. Covered some good ground. Think there's a lot more to talk about in future episodes, hopefully, and then we'll introduce some other Ada Mode folk and guests as well in the future. Yeah,
you touched in your intro on sort of optimization of plant and like influencing how the plant is running, like supervision and guidance for plant control and operation. That's a really interesting area. So probably a whole podcast worth in that.
Oh, a little teaser for the future. Cool. All right, we'll call it a day. Cheers, guys.
Thank you.
Thank you.